Hello guys, welcome back to my YouTube channel. This is Nehati from Sri Venkateswara College of Engineering, and today I'm here with a video on binomial distribution. So before starting the video, please do like, share, and subscribe without fail. So let's get into the video. So the contents for today are we'll be seeing what is binomial distribution, then we'll go to the formula, properties, then derivation for mean and mean variance and standard deviation. After that, we'll see two examples for how to solve the binomial distribution and then the applications in real life, and we'll conclude the video with that. So, what is binomial distribution? Binomial distribution is the discrete probability distribution that gives only two possible results in an experiment, either success or failure. So, binomial itself in the name says that it has only two outcomes. So, either it will be success or failure, and in case of tossing a coin, we have only head and tail, that is two outcomes. Then in a test, either it is passing or failing. So, these are the examples for binomial distribution. Then binomial distribution formula. So the binomial distribution formula for any random variable x is given by p of x is equals to combination of ncx p power x into 1 minus p to the power n minus x. So 1 minus p, we can even take it as q, that is the what it if p is the probability of success in an experiment, q will be a probability of failure, that is not p, that is 1 minus p. So and n is the number of experiments. X varies from 0 to infinity. So next one is the properties of binomial distribution. The properties of binomial distribution are there are two possible outcomes, true or false, success or failure, and yes or no. There is n number of independent trials or a fixed number of n repeated trials. So what are independent trials? Independent trial means that the outcome of that one experiment or a trial does not affect the other trials. Okay, so there is n number of independent trials or fixed number of n times repeated trials. The probability of success or failure remains the same for each trial. Only the number of success is calculated out of n independent trials. So again, the last one is the definition for independent trial. Every trial is an independent trial, which means that the outcome of one trial does not affect the outcome of the other trial. Okay. So coming to the derivation of mean of binomial distribution. So here first mean is equals to mu, which is equals to sigma x, a summation of x into p of x. So this summation x into p of x, we saw the formula for p of x, that is ncx p power x to the n into q to the power n minus x. So that is the formula for p of x in binomial distribution. So p of x will be replacing by the formula ncx p power x into q power n minus x. This is equals to summation x into ncx, we can write it as n factorial by x factorial into n minus x factorial into p of x into q of x power n minus x. Okay. So after that, this x factorial will be writing as x into x minus 1 factorial, that is a formula. And then we can cancel these two x from numerator and denominator. Then we'll be left out with n into n minus 1 factorial by x minus 1 factorial into n minus x factorial p power x q power n minus x. The next step will be n into n minus 1 factorial. This is what we get after taking off x from numerator and denominator. Then we'll do n minus x. We can write it as n minus x plus 1 minus 1 is equals to n minus 1 minus x minus 1. We can write this n minus x as n minus 1 minus x minus 1. So we'll substitute this n minus x in as the same, this one, in n minus x factorial, that is in the denominator, and for q power n minus x, we'll substitute it. Then we'll be taking n and p together. After that, the remaining whole part, that is the n minus 1 factorial by x minus 1 factorial, n minus 1 minus x minus 1 factorial into p power x minus 1. This p, we can write it as p power 1 into p power x minus 1. So remaining will be, if p is taken that side, we have p power x minus 1 into q power n minus 1 minus x minus 1. So this will be taking as p plus q power n minus 1. and p plus q per n is equals to 1. So 1 per n minus 1 or 1 per anything will get 1. So we'll have np into 1, which is nothing but np. So this is the mean for binomial distribution. Coming to the next one, the standard variance and standard deviation of binomial distribution. It is kind of similar to the mean, but with little variation. So v is equals to variance is equals to summation x square into p of x minus mu square. This will take it as 1. Okay. So after that, we'll only take the summation x square p of x and we'll substitute it first, and then we'll bring the minus mu square later on. So this x square into p of x, we can write it as x square, we can write it as x into x minus 1 plus x, okay, into p of x. Then we'll multiply p of x with the two terms over here. We'll get x into x minus 1 into p of x plus x into p of x. So x into p of x is nothing but np, that is mean. We'll write np over here. This one we can write it as x into x minus 1, and p of x formula ncx p power x into q power n minus x. So again we'll take x into x minus 1. This one we'll take it as n factorial x factorial x factorial into n minus x factorial p power x and q power n minus x plus np. np came from this x into p of x. After that, this x factorial will be writing it as x into x minus 1 into x minus 2 factorial for the variance and standard deviation, because we have to strike out this x into x minus 1. So after that, we'll be striking out x into x minus 1 from both numerator and denominator. Now we'll be left out with n into n minus 1 into n minus 2 factorial by x minus 2 factorial n minus x factorial p of p power x q power n minus x plus np. So like last time, we'll be taking n minus x, but here we'll be doing n minus x plus 2 minus 2, and for that we'll be getting the answer of n minus 2 minus x minus 2. So that will be substituting wherever we have n minus x. So now it becomes n into n minus 1, n minus 2 factorial p square p of x. That time we did it as p into p of x minus 1. Here we'll be doing p square into p of x minus 2. So p power x minus 2. And then we have q, n minus x is replaced as n minus 2 minus x minus 2 plus np. Here also we'll be doing the same. Then we'll group n into n minus 1 into p square. We'll be grouping this, and the remaining one will be grouping over here plus np. np will be over here. So this will be taken as p plus q power n minus 2. Here it is n minus 2, so we'll be taking as n minus 2. In the previous one, we took it as n minus 1. So now it becomes n into n minus 1 p square p plus q per n minus 2 plus np. And p plus q per n is nothing but 1. So 1 per n minus 2 will take, and 1 per anything will be 1. So we will get n into n minus 1 p square plus this np. This will be taking as equation number 2. Now we'll bring the equation number 1. We've substituted only this first term. So now we'll use even the second term, that is minus mu square. Minus mu square is nothing but np the whole square. So we'll take the whole equation 1 now, and we'll be substituting it. So now we'll get v is equals to n square p square minus np square plus np minus n square p square. This is what we'll get. The first term and the last term will be cancelled because one is positive and one is negative. Now we'll be left out with minus np square plus np. We'll group the np together, and then we'll have 1 minus p, and 1 minus p is nothing but q. So v is equals to npq, and variation is equals to npq, and standard deviation is nothing but root of variance, that is root of npq. Okay, so this is about the derivation for mean, variance, and standard deviation. Next we'll be solving two problems related to binomial distribution, two easy problems. So if a coin is tossed 5 times, find the probability of exactly 2 heads, at least 4 heads. Okay, so this is the question. So number of trials we have is 5. It's mentioned there in the question. So probability of head, if a coin is tossed, we either have only head, either we'll get a head or either we'll get a tail. There are only 2 possible outcomes. So probability of head will be 1 by 2, and probability of tail is 1 by 2. We can even take it as 1 minus p, that is 1 minus 1 by 2 is equals to 1 by 2. So exactly 2 heads. We'll take x is equals to 2. Probability of x is equals to 2 will be, we have the formula. We'll go with the formula over here. It is ncx, and we have taken as 5 in that question. X will be 2. because it is exactly 2. P power 2, Q is also P is 1 by 2, 1 by 2 power 2, and 1 by 2 power, uh, what is that? N minus 2, 5 minus 2. So that is the thing. Okay, so if you're taking like that, we have we will be getting 5 factorial. 5C2 will be taken as 5 factorial by 2 factorial into 3 factorial into 1 by 2 square into 1 by 2 cube. Okay, that is 5 minus 2. We'll be getting P of x is equals to 2 will be 5 by 16. For the next B part, we have for at least 4 head. At least 4 head will be x is greater than or equal to 4. Okay, so P of x is equals to 4 and x is equals to 5 will be taken here in this case because we have the n is 5. So P of x is equals to 4 and x is equals to 5 is what we'll be taking here. Then we'll be calculating P of x is equals to 4 separately and P of x is equals to 5 separately. We'll be getting 5 by 32 and 1 by 32. And then for the final value, that is P of x greater than or equal to 4, we'll be taking sum of those two and then we'll be getting 3 by 16. Similarly, we have another problem. The probability that a pen manufactured by a company will be defective is 1 by 10. If 12 such pens are manufactured, find the probability that it will be exactly 2 heads. Two will be defective, at least 2 will be defective, none of them will be defective. So the answer will be probability is already given in the question, that is p value, p is equals to 0.1, and q will be taking as 1 minus p, that is 1 minus 0.1, which is 0.9, and n here will be taking it as 12. First one, exactly 2 will be defective. We'll use the equation again. We'll take x is equals to 2 in that case. In the b part, and then if we solve it, we'll be getting 0.2301. At least 2 will be defective. At least 2 will be taking p of x is equals to 0, 1 minus p of x is equals to 0 plus p of x is equals to 1. This is what we'll take. Okay, so we'll be getting 1 minus so and so. So the thing 12C0, 0.9 to the power 12. We even have 0.1, that will be 0.1 to the power 0. So it will be 1 and that we have not mentioned it here. Then plus 12C1 into 0.1 to the power 1 into 0.9 power 11 will be getting 0.3411. And finally, we have the probability that none will be defective. We'll be taking x value as 0 and here it will be 0.2824. So this is about probability distribution. Coming to probability distribution in real life, where will we use it? In real life, the concept is used for checking whether the number of people view a particular channel by using the yes or no survey. Either it is yes or no. So to find the number of male or female employees in an organization, so either there will be male or female employees. The number of votes collected by a candidate in an election is counted based on 0 or 1 probability. So that is what it is, where we use binomial distribution in real life. So coming to the end of the video, we have binomial distribution can only have two outcomes. The characteristic of one will be positive and the other is negative. Statistics and other mathematical fields make use of binomial probability distribution for finding the outcome of a set of independent experiments. So this is all about today's video. We learned about binomial distribution, the formula, properties, how to find mean, derivation for mean, standard deviation, variance, everything. So that's it for the video. I hope you all enjoyed and learned something from this video. And please do like, share, and subscribe to my channel without pick. Thank you, everyone.